All right. Sorry I lied. There's actually two more problems today. Okay, so let's start with the next problem. Is we're going to find the largest rectangular cube with sides parallel to the coordinate axis that can be inscribed in the ellipsoid x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Okay, now I'm going to tell you guys just honestly right now, I love this problem so much that it will more than likely show up on an exam, or some version of this problem will show up on an exam. Okay, what are we on? Video 7. I didn't always like this problem, but I do now. Okay, so this problem becomes, in terms of just setting up what is the problem, we want to maximize f of x, y, z equals x times y times z, and we have a constraint g of x, y, z equals x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. Okay, now I'm going to first, one of the things that is sort of a strength of mathematics is we try to make our problem easier if we can. So let's look at an easier version of this problem first. Okay, so an easier version of this problem is, let's maximize f of, let's say, u, v, w with our constraint g of u, v, w equals u plus v plus w equals 1. We've actually already done this problem, haven't we? Did this problem way back here in video 5. I mean, not exactly, but almost. Okay? Actually, u squared. There we go. That makes it easier. That makes it different, but that makes it more like this problem. Okay, so, you know, we could do it. It's going to be the same thing, but you're going to sort of get the sense that u equals v equals w equals 1 over the square root of 3. Let's do that because we should. Okay, so we get vw equals 2 lambda u, uw equals 2 lambda v, uv equals 2 lambda w. Let's multiply this by u, this by v, this by w. So u squared equals v squared equals w squared. I didn't need to find lambda, okay? So in this case, they're all going to equal 1 over the square root of 3, or at least u, v, and w are. Actually, absolute values, I should say. Okay, so that's going to give us our answer. And they're all going to be maxes. We're going to be either have maxes or mins, but they're all going to occur at these different places. Okay, so you're either going to have a min, well, largest rectangular cube. So we're maximizing. So we're actually going to use basically, right, well, you're basically going to have 1/3. Sorry. So the largest cube, okay, or largest rectangular cube has volume 1/3√3. Okay, now let's go back to the original problem. Maybe like, well, why did we do the hard one? This one's got all the bad algebra. We're going to get rid of the bad algebra. We're going to make a substitution. So let's substitute. Okay, so we're going to make the substitution. U equals x over a. V equals y over b. And w equals z over c. Okay, so then our new problem becomes, let's call it f tilde of u, v, w. So now x is a times u, y is b times v, z is c times w. So we're going to get abc times u, v, w. And our g tilde is going to be u squared plus v squared plus w squared equals 1. Well, when it comes to maximizing, this ABC doesn't really make a difference, right? I mean, we're still maximizing u times v times w, right? So, look at that. We just have this problem now. Going through all the stuff we just did, u equals v equals w is 1/√3. Okay, so x is going to be what? X over a is u, so x is going to be a/√3, plus or minus. Y is b/√3, plus or minus. Z is c/√3, plus or minus. Okay? And this is going to give you all your maxes and mins. The max is really when you have a net positive sign. So if you have either all of them are positive or two of them are negative. Okay, that's going to be your max place. Your mins are going to be when you have one of them being negative. Okay. All right. Let's do one more. Because this trick is so good, we're going to do it again. So, example problem. Find the volume of the largest rectangular box in the first octant with 3 faces on the coordinate plane and one vertex on the plane x plus 2y plus 3z equals 12. Okay, so let's draw that picture. I don't think I've actually talked about how to draw a plane like this, at least not in the videos. Okay, so if I want to draw x plus 2y plus 3z equals 12, one easy way to do that is to imagine these other things being 0. So like if y and z are 0, you have got x equals 12. So let's put that one in there. Let's imagine that we're going by 2's there. So that's one vertex of the plane, or that's one point on the plane, 12, 0, 0. If x and z are 0, you're going to get y equals 6. And if x and y are 0, you're going to get z equals 4. I'm going by 2's here. Okay, so you have a plane that looks like so. Okay, now what is it that we're trying to maximize? We're trying to maximize, of course, x times y times z. And what is our constraint? X plus 2y plus 3z equals 12. Okay, this is not a symmetric problem. All right, this is not symmetric. But what were we going to do? We're going to make it a symmetric problem. So let's let u equal x, v equal 2y, and w equal 3z. Okay, so our f tilde of u, v, w is going to be what? X is, so this is going to be 1/6 u times v times w, still symmetric in u, v, and w. And our constraint is u plus v plus w equals 12. Now we still should walk through it just in case anything unexpected happens as far as doing the Lagrange multipliers here. But we have an expectation. Our expectation is that u, v, and w should all equal 4. Okay? Let's walk through that. Gradient of f equals lambda gradient of g. So expect. And we're just going to make sure that that happens. Because sometimes, I haven't come across it, but sometimes some crazy situation could happen where it doesn't actually work. Okay? So we should walk through it. So what do we get? We get 1/6 VW equals lambda. 1/6 UV, sorry, UW equals again lambda. 1/6 UV equals again lambda. Again, multiply by the appropriate thing. 1/6 UVW equals lambda U. 1/6 UVW equals lambda V. 1/6 UVW equals lambda W. U equals V equals W, which then has to equal 4. Okay, so what's that give us? X equals 4, V equals 2, and W equals 4/3. Oh, sorry. That should be Y and Z. Okay? All right. So, for a lot of the problems, for just an extraordinary amount of the problems that you're going to see in this section, you can use this sort of symmetry trick. Okay? So, go forth and optimize.